we're going to talk about how to solve systems of linear equations. That means in this example, we have three linear equations and we are looking for the points that they intersect. When you have three equations and you want to solve them algebraically, look for the easiest ones to solve first. For example, when you look at this b right here, you could easily divide by 2 and then already have b, which is 1. So now we're going to look for the next easiest one. When I look at this line, now that I know b, u is pretty easy to find. So I'm going to plug in the 1 for the b that we just found, plus 2u equals 13. Now I'm going to solve for u. This is 5, so I'm going to subtract this 5. So that would be 8. Divide by 2. U is 4. All right, so now I have two of the variables. The only thing I'm missing is y to have all three of them solved. So the only one equation that has a y in it is the first equation, so I have to use this one. So I'm going to plug in 1 for the b. I'm going to plug in 4 for the u. And the only variable I have there is y, so I'm going to go ahead and solve for y. So 1 plus 8 is 9. Subtract 9. So that leaves me with 15. Divide by 3, and y is 5. And generally when we write our answer, we write our solution in alphabetical order. So it would go b is 1, u is 4, and y is 5. That would be our solution for this system. That would be the point of intersection of a 3D plane of these three linear equations. I have one more example for you. This one is much more challenging. So I am going to actually number the three. We again have a system of three linear equations. I'm going to number them so that when I do an operation, you know what line I'm referring to, because we're going to keep coming back to them. So when you have a system like this, there's not one variable to easily solve for. But remember that using elimination, I can multiply rows by something to make something eliminate. I notice that this y, for example, if I multiplied this by 3, if this was a 3, this would cancel. I also could multiply it by 2 and get these to cancel. Remember, in elimination, you want something to eliminate. So my first thing that I'm going to try to do is to get this to cancel. So I'm going to take row 1 and I'm going to multiply it by 3 so that I can get these y's to cancel. So when I multiply by this 3, I'm going to get 6x minus 3y times 3 times 3. Okay, I'm going to copy row 2 down because I'm going to add these rows together. All right, now I'm going to add them together. And again, remember the goal was to get one of the variables to eliminate, which they did. So when I add this, I get 10x and 7z and negative 1. Now, we still don't have a variable yet, but we are closer. What I want to do is I want to eliminate a y again using these, because then I'll have an x and z system that I can put together and solve. So this time I'm going to take row, let's see, I was going to do 1 and 3. So I'm going to multiply row 1 times 2 this time. My goal is to get these y's to cancel. So I'm taking row 1 and I'm multiplying it by 2. So that's going to leave me with 4x times 2 will be negative 2y, times 2 will be negative 6z, and times 2 will be 2. I'm bringing over row 3, so I'm just copying it over because I'm about to add these together. Remember, the ultimate goal is to get the y's to cancel, which they do. That would be 0. All right, so now these add up to be x and negative z and -1. Now, this doesn't look like much, but it is really helpful because now I have two equations with an x and a z that I can now multiply to get them to cancel. So I could multiply this by -7, or I could do this by -10. As long as something eliminates, you're doing your job. I'm going to multiply this row by -10 to get the x's to cancel. So I am multiplying this times 10. So this is going to be, and I'm actually going to do a -10, that way they will cancel. So this will be -10x. That will be a positive 10z when I multiply by -10. And -10 times -1 is positive 10. All right, now I'm going to add these rows together. Remember, the goal was to get another variable to eliminate, and I just did. So this is going to be 3z equals 9. Look at there. Now I finally have one variable. Z is 3. Now, don't get discouraged. The first one is the hardest to get. It does get easier from there. So now that I have one of the variables, I would like to find an easy place to plug this in to get another variable. What I notice is over here, I have a z almost solved with the x. So I'm going to use this 3 that I know now is z, and I'm going to plug it in for z, and I'm going to solve for x. So when I add 3 here, x is 2. Okay, so we now have x and we have z. So we need to now find y. That is the only variable we're missing. The good news is this is the easiest one to find. It does not matter which equation you decide to use. You're going to plug in your known variables and use that to solve for y. So I'm just going to choose row 1. And I'm going to plug in the x that we know, so 2 times 2 that we just solved, minus y, remember that's the one we don't know, minus 3 times z, which is the 3, equals 1. Now we're going to solve for y. So 2 times 2 is 4, 3 times 3 is 9, 4 and -9 combine to be -5. Add 5 to both sides. And then to get rid of this negative, we're going to divide by -1. So y is -6. All right, so now we have all three variables. Our ordered triplet is 2, -6, 3. That is our x, y, z coordinate where the three linear equations will intersect. Remember that to check your answer, you would plug this in for x, y, and z, and it should equal for all of these rows. If you plug it in, then you know for sure that you got the right answer. These take a lot of practice, so make sure you practice these, and remember to begin by looking at which of the variables would be the easiest to eliminate. That's going to be your easiest way to start. There's lots of right ways to solve these problems though. So don't get frustrated, just keep practicing and be careful with your adding and subtracting and multiplying because that's where students usually make mistakes. Good luck and make sure you practice.